This question is from GATE 2017 Mechanical Engineering paper, set 2, question number 52. A strip of 120 mm width and 8 mm thickness is rolled between two 300 mm diameter rolls to get a strip of 120 mm width and 7.2 mm thickness. The speed of the strip at the exit is 30 meter per minute. There is no front or back tension. Assuming uniform roll pressure of 200 megapascal in the roll bight and 100% mechanical efficiency, the minimum total power in kilowatt required to drive the two rolls is dash. Let's find out. So this is how the rollers look like, and the change in thickness is from 8 millimeters to 7.2 millimeter. So delta H is H1 minus H2, which is 0.8 millimeter. Also, roll radius is 150 millimeters because roll diameter is given 300 millimeter. So just half of it will be the roll radius. Both rolls have the same radius. We are to calculate the power. So power required will be torque on the roller into its angular velocity omega. But there are two rollers, so we'll multiply this quantity by 2. This is the total power. Now, torque can be calculated using the tangential force F into the arm length A, where arm length is equal to 0.5 times LP for hot rolling, which gives us the arm length. And omega then can be written as 2 pi n by 60 into 2. A can be found out from here. F can be found out using pressure P into the area AP, where AP denotes the projected area. There are many variables to be calculated in this question, so we'll calculate them one by one. Now, to calculate the projected area AP, we do contact length LP into the width B. Now contact length is required both for calculating arm length and for calculating the projected area. So let's find the contact length. Contact length LP is given as under root roll radius capital R into change in thickness delta H. So LP will be simply under root 150 millimeter into 0.8, which is nothing but 120. So LP is under root 120, which is 10.954 millimeter. Now let's substitute to find out AP and A. AP will be 10.954 into 120 and small a will be 0.5 into 10.954. AP turns out to be 1314.534 mm square and A turns out to be 5.477 mm. Now we can put value of AP here to find out F. P already is given as 200. So we have force F equal to 200 into AP is 1314.534. So force F is, in terms of Newton, we get it as 262910. So to convert to kilonewton, it is 262.91 kilonewton. Now we have the value of F. We have the value of A. We require N. So final velocity Vf is given to us. We don't know the initial velocity Vo because V is actually the velocity of neutral plane from where we can calculate omega. So velocity of neutral plane V will be equal to omega into R, and this V is the velocity of neutral plane. So to find that, V will be V0 plus Vf by 2, just the average of initial and final velocities. We need to find out initial velocity V0 or velocity at the entry. So to do that, we'll use the continuity equation. Using continuity equation, we write A0 V0 equal to AF Vf. A0 can be written as B into H1 and AF can be written as B into H2. So B is equal on both sides, can be divided to 1. So we have H1 V0 equal to H2 Vf. From here, V0 is equal to H2 is 7.2 into final velocity Vf is given as 30 meter per minute divided by H1 is 8. This gives us V0 value to be 27 meter per minute. So we can find V from here. V is equal to 27 plus 30 by 2, which is nothing but 57 by 2, 28.5 meter per minute. Now let's find power finally. Power P is equal to 2 into F is 262.91 into arm length A is 5.477 but this value is in millimeter. So let's convert it to meter into 10 to the power minus 3 into, we have to find out omega using V. So omega is equal to V upon R, and V is 28.5 meter per minute. So omega will be, in this we need to have V in terms of meter per second. So to convert minute to second, we divide this value by 60. So we have 28.5 divided by 60 into, roll radius is 150 millimeters. Convert it to meter, we have 150 into 10 to the power minus 3 in meter. So let's substitute this here, 28.5 divided by 60 into 150 into 10 to the power minus 3. We can also find out n and then put it here as 2 pi n by 60 as we wrote earlier. But finding out omega is easier. So this, when calculated in digital calculator, will give us value of power as 9.119 kilowatt. Remember, we have substituted F in kilonewton and all other units have meter in them. So we'll get the power value directly in kilowatt. Let's go back and fill in the answer. So the minimum total power required to drive the two rolls is 9.119 kilowatt. To learn about rolling in detail, you can refer to the NPTEL video, Metalworking Processes Rolling. It's from the course Fundamentals of Manufacturing Processes. The course is by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering Department of IIT Roorkee. I hope this solution will help you clear your doubt. Thank you.